to Almighty Tricks. Today we will be understanding L of solid. L stands for Liskov Substitution Principle and it is defined by Barbara Liskov in the year of 1988. Okay, so let's understand the definition. So definition is very easy and it is saying that object of every child class should be substitutable with a variable of parent class without changing the code. And when we put an object of a child class, it should not require us to make any changes to the code base, and no child class should require any special treatment. Okay, so let's understand in a whiteboard each and every point with a beautiful example. Let's get into the whiteboard. So I have class A and B and C. So B and C are extending class A. So let's say I want to create one object. Okay, sorry, A is equal to new B. Okay, so in this case, so let's say in this way I am creating the object. Let's say in place of B, I want to put C. Okay, so this first definition is saying if I am replacing with one child class to another child class, so we no need to change anything, so it will easily replaceable. Okay, so let's understand with a beautiful example. So let's say we want to create a bird class. So this bird class, basically I have this bird class which is an abstract type, and I have some attributes and I have some methods like bird can walk and bird can fly. Okay, and I have two more classes. That is crow class, and I have another class that is parrot class. Okay, so these both two classes are extending this bird class. Okay, so I need to as it is extending this bird class, I need to override these two methods, right? I need to override this walk method here, and I need to override this fly method. And logically also, crow can walk and crow can fly, right? So similar way, parrot can walk and parrot can fly. Correct. So basically, if you see here, I want to create the bird object. Let's say bird P is equal to new crow. I'm creating crow. Okay. So basically, from here I can call walk method and I can call fly method. Correct. Let's say this crow object is there, right? So let's say in place of crow, can I use parrot as well? Yes, I can use, because because parrot has walk method and fly method, so we no need to do any changes here, just we need to change here, right? So as it is, we can use. Okay, so basically it means what? So it means what? Bird B can be used new. I can use here crow, I can use, or I can use parrot. Okay, so it means what? So basically these child classes, like, so individually each subclasses are responsible to do their task in their own way. Okay, and we no need to change any code modification, right? We no need to do any code modification, so as it is it will work. Okay, no need to do anything. Okay, so basically this scenario is satisfying LSP. Let's understand another example. Let's say I have another class. Let's say I have another class, penguin class. Okay, and this penguin class also, it is overriding this, it is extending this bird class, and we need to override these methods, right? Walk method and fly method. Okay, but observe one thing here, penguin cannot fly, right? But we are using this fly method. But here basically when we create the object of penguin type. Let's say we are creating object of penguin type. So in this case, this fly will not call, right? It will throw some error. It will throw some error. So to handle this error, we need to handle the error here. We need to handle error in this penguin class. Okay, so it means what? We need to, like, this class needs special treatment. Okay, so basically it is breaking this point and this point. So basically this scenario is violating LSP, violating Liskov substitution principle. Okay, let's understand how we can solve this scenario. Okay, so what I did, I have created this bird interface and flybird interface. Okay, so the to solve that LSP issue, so for the recommended way to use the convert the class into interface. So basically previously I used to have the abstract bird class, right? So now it is converted to uh, a bird interface. Okay, so in the bird interface, what I will put, the bird interface will responsible to have the common function. So common function means crow can work, parrot can work, and pigeon can work. So I can have work method here. Okay, so as work is a common function, so what I'll do, I can extend, I can implement this bird, right? I can implement from crow and parrot, right? So I can implement this bird interface. So now I need to override this work method in the crow and work method in the parrot. Okay. Now, now I have also created this flybird interface. So flybird interface basically responsible to have the fly method. Okay. So basically crow can fly and parrot can fly, but penguin cannot fly. So what I can do, I'll implement this flybird from crow and parrot. Okay, and one more thing here, penguin can work only. Penguin can work. So I'll not implement this flybird. I'll implement only bird. Okay, fine. So basically this is satisfying the Liskov substitution principle. Let's take another example. This bird interface has a swim method also. Swim method. But if swim method is present in the bird, so I need to present this swim method here also, right? Here also I need to put the swim method. So now if you observe, crow and parrot cannot swim, right? So I need to, these two classes need special treatment, right? I need to handle the exception here. Okay, so special treatment is there, and so we need to change the code which is violating LSP. Okay, so basically what I can do, I'll not implement this swim method inside the bird interface. What I can do, I can create another interface called swim bird. Okay, so I have created this swim bird interface and I have swim method. So as penguin only can swim, so what I'll do, I'll implement this swim method from the penguin. Okay, so basically this swim method can be override. Okay, let's say in the requirement it is given like we need to fetch only flying bird. Okay, so we need to find the list of flybird. So we can if our code structure is like this, we can get the flybird, right? So flybird only crow and parrot, right? So we'll get the crow and parrot. Let's say we want to fetch the swim bird. So in the swim bird, basically we have only one swim bird, that is penguin. So basically it is satisfying this code structure is satisfying LSP. So let's understand practically. I'll code this in a IDE. Let's understand that. So I have created this LSP package. So in the LSP package, I have created this bird interface, which is having only walk method, which is common for all the birds, crow, parrot, and penguin. And I have created this fly bird interface, which is having only fly method. And this fly bird interface is used by crow and parrot, as crow and parrot both can fly. So I have implemented this bird and fly bird. So I can override the walk method and fly method, right? So I can have the logic for those two methods. Similarly, in the parrot class also, I have implemented this bird and fly bird interface, and I have override this fly and walk method, and I can have the separate logic for the parrot. Okay, but for penguin, penguin cannot fly, right? So I no need to implement this fly bird. I can have only fly bird. I can have only bird interface implementation here, and I can override this walk method. Okay, so I can have the different logic for the penguin work. Okay, similarly, let's say I need to support the swim birds, the bird who can swim. So for that, I need to create one interface called swim bird. Okay, so here basically I need to have one method, swim method, and here basically penguin only can swim, right? Parrot or crow cannot swim. So here basically I need to, in the penguin class, I need to implement this swim interface. Okay, and I need to override the swim method, and I can have the logic for the swim. Okay, so this is all about the LSP. Hope you understood the concept. Thank you for watching this video.